fork. And now what a fork is, so I've already forked the repository, but you click that and then you end up with your own fork of the AstroPi repository. And what a fork is you can think of it as like a separate copy of the remote. It's taken the AstroPi project and created another whole remote repository that now you do have access to. So I have this Jake VDP/AstroPi project that's a completely separate thing. I can do whatever I want with it, and it doesn't affect the main AstroPi repo. But the most useful thing you can do with it is kind of use it as your own working copy of AstroPi. And what you can do next is all the stuff that you've learned, you go to here, you clone it, get a local copy of it, you make some changes, you push up a branch, and actually I might even do this right now. Let's do everything but open a pull request to show this. So I'm gonna cd temp, and I'm gonna git clone my AstroPi repository. So, and it'll take a little bit because AstroPi is relatively big. And hurry up. Okay, now in AstroPi, let's say the change that I want to make is that I want to add a file called jakerocks.md, and we'll just make it the title Jake Rocks, right? So there's my file, and this is my awesome contribution to AstroPi that I'm just about to embarrass myself on the internet with. You do git status, and you find that file there. So you do this. Well, one thing that's usually good to do if you're doing some sort of contribution, some sort of new thing, is just to keep things clean. Let's put it on a branch. So I'm going to git checkout -b Jake Rocks. That's my branch name. So I'm on this new branch called Jake Rocks, and I'm going to git add the Jake Rocks file and commit -m Jake Rocks, and then do git push origin Jake Rocks. So here, instead of pushing my master branch to the origin, I'm pushing this new thing to the origin, right? Now, when you go here on GitHub, you'll see that GitHub is smart enough to say, hey, you recently pushed this new branch called Jake Rocks, and there's this button here called compare and pull request, and you click that, and what it does is it generates this pull request that says, I want to take my Jake VDP AstroPi Jake Rocks branch and put it into AstroPi master. You can put a title here, which is Jake Rocks, right? And please accept my awesome commit. And you preview it here. And this is like, if I clicked this button right now, I would have to buy several people beer just to make them forgive me for being thing. But basically, once you click that button, what it'll look like, if we go to the AstroPi site, and I'm going to close this so I don't accidentally do anything I regret. If you go to the AstroPi site, it'll create something like this, a pull request. So here's a real pull request someone did. Provide a decorator for replace parameters. I don't know what this does. But once you have this pull request, the person who put this code here did essentially the same thing. Had this branch called replace parameter decorator and wants to merge it into master. And you get this view that says the files are changed right here, and you can see exactly what was changed. Here's this new decorator. Here's the function that was added to AstroPi. So you get a look at all of this, exactly what's going on, and whoops, that's not what I wanted. I wanted to go back to the conversation. And then on top of that, you have this conversation where people can comment on specific places in the code. You can do a code review, and you can talk about various things, and then talk about why I did this, why I did that. And then in the end, when everything is all set, the person who has permission to modify the repository can click a merge button. The merge button appears right here for the people who have permission. I don't have permission, so I can't merge it. But once you do that, then it's like doing a git merge on your laptop, except it's happening on the remote on GitHub. And that new code is then part of the AstroPi project. So this is how you can work with people on GitHub without actually giving them permission to your own repository, or without getting permission to modify theirs. And this, in my mind, is the real power of having something like GitHub, is people around the world can work together on these projects. And it's just using all the little like command line tools that we went over the past couple hours, and gets you there. Yeah.
So if you have an open pull request, so say for example, for this pull request, they ask that you change some code before they accept the pull request. When you change that code, will it pull request the latest commit in the branch that you're pulling, or does it pull that specific commit?
Yeah, that's a great question. So if you change any code in the same branch and you push it back up to GitHub, then the pull request just keeps up with the newest version of that branch. So you don't have to, if you have to change something, you don't need to open a new pull request. You just update your branch, and you might even be able to see this here. I guess it didn't happen here, but you can actually see in some places. You can see in some places where people add commits after some conversation. So this one, yeah. So here are the first couple commits that CMC colleague put in, and then they had said, I think this should be made more clear, and then he puts in some other commits and adds some things. The other cool thing is that on projects like this, see this little check mark right here? I'm going to talk about this a little later. What they have set up is something called continuous integration. So when you put a commit in the pull request, it spins up a virtual machine and checks the new version of the code and makes sure that all the unit tests pass. So this is really nice, because then you can make sure that any new commits actually don't break your code base. So here's one that failed, and you can see it was the app.bear PR that failed. And you can click in here. Oh, this was failed because it was canceled because there was a new commit. But anyway, it's a nice tool for making sure that your code is always in a good state and the project is always in a good state. So this is why one reason why you can trust that AstroPi is going to work, because they have this continuously integrated unit tests going on. So anyway, that's the GitHub stuff, and trying to figure out the best use of our time right now. It's a little bit after 4. Why don't I introduce what we're going to do in the last session of the day, and then give you another little break before we dive in and do things. So I've finished what I want to tell you about Git and GitHub now. So now you're all experts, and you can run off and start doing your own thing, your own work on Git and GitHub. But this Git and GitHub stuff underlies a lot of these software engineering principles that are going to be really important in doing your work in an effective and reproducible and open manner, which we'll talk about. So what I'm going to do in the last maybe hour and a half that we have together before we break tonight is walk you through the process of moving from data exploration to the creation of a Python package, to writing a few unit tests to make sure your Python package works, putting it on GitHub, and then registering with these continuous integration services so that you can see that your package is always running and the unit tests are working. So I'm hoping that we can do that together in about an hour and a half. I'm going to start from scratch and just make a new repository on my computer and have all of you type along at the same time and do this. And I'm hoping that after an hour and a half and walking through this step by step and having you do it on your own with your own keyboard, that you'll be able to kind of remember how to do this in the future and start doing your own projects that way. So we're going to take another quick break, and after that we'll dive into some software engineering, creating a Python package, putting it on GitHub, writing unit tests, and having continuous integration check them all the time. All right, so let's break for 15 minutes or so, and come back at 4:20.